Welcome everyone. My name is Rob Zarnecki, and I look after product management for the Archive S3 storage classes, which are S3 Glacier and the brand new S3 Glacier Deep Archive, which launched at the end of March at the Santa Clara Summit. Just to set a little context for what we'll talk about today, talk about the Archive S3 storage classes, particularly how to use Glacier Deep Archive, our partner network integrations on the storage side, and spend some time on economics and use cases so you can better understand which workloads work well with our asynchronous archive storage classes and which are maybe better suited for something a little bit warmer. Just to do some early definitions for those of you that have been talking in acronyms for the past couple of days, I'll mention a handful of Amazon services during the talk today. Primarily Amazon S3, our simple storage service, which is the object storage designed for the internet, to put it very briefly. Our archive storage class, Glacier, which is just about 7 years old now, and the new flavor of Glacier, so to speak, Glacier Deep Archive. We'll talk about our AWS command line interface, our simple queue service, and our simple notification service, both of which are fully managed queuing and messaging services, which can be helpful in managing an AWS workload at scale, and AWS Lambda, our serverless compute offering. So just to step back and talk about S3 as a whole, we now have 6 storage classes which we offer, and they really run the gamut and allow you to choose the right storage class for your specific workload. S3 Standard, which provides millisecond access for that really warm, hot, active data. When you use S3 Standard and any of the S3 storage classes, with the exception of one zone infrequent access, we're going to spread that data across at least 3 physically separated availability zones. Our architecture is designed such that we could lose an entire availability zone and then still have some technical problems within one of the remaining zones, and your data would still be available to you. That's above and beyond the redundant power that we have and the way our system is designed. It's part of our availability and our durability that we promise when you bring your storage to us. But the trade-off with S3 Standard is, while you get this great access, you have a very simple economic model. You pay for puts, you pay for gets, and you pay for storage. The result of that is the storage price becomes slightly higher. So as we heard customer feedback that they had workloads which were less active and where they would be willing to pay retrieval costs to get the bytes when they need them, as opposed to always having that availability, we built standard infrequent access. And what that does is it really shifts the model of storage, so to speak, and allows us to offer a reduced storage cost, and in return ask our customers to pay a retrieval cost when they do need to access those bytes. And what we heard over time was that some customers had a tough time determining if standard or infrequent access was correct for them, because unsurprisingly, an object that's in S3 standard infrequent access that is accessed more frequently could end up costing more than an object in standard. So last year we built intelligent tiering. And what intelligent tiering does is it looks at your access pattern and it will move that object for you between S3 standard and standard infrequent access, allowing you to enjoy the cost savings when you're not accessing that object, but to move it back and have the simplicity of S3 standard when you do need that object. We also have the one zone infrequent access, which provides additional savings if you're willing to give up the multi availability zone redundancy that we offer and cluster that data, which is still 11.9's durable, still the same availability promise in a single physical location. And then we have the infrequent or the archive storage classes, Glacier and Deep Archive. Now the millisecond premise goes out the window with the archive storage classes, and you're talking about minutes to days to get access to those bytes. The big logical change there is you first do a restore before you're able to get the objects. And with Glacier, we offer the availability to expedite those restores and have your bytes back within minutes. or to save some money on the restore cost and wait up to 12 hours. With Deep Archive, we wanted to double down on that model. And in doing so, we were able to reduce the storage price while extending those retrieval times to 12 and all the way out to 48 hours. So if your system is able to tolerate that 48-hour restore time, you're able to enjoy some really nice savings on the storage cost that you'll pay month over month. So to get a little bit deeper on what Deep Archive is, more than 95% of the features that we deliver at AWS are a direct result of our customers' feedback. And what we heard loudly and clearly from customers was, Glacier is great, but this is cold data. I don't need the concept of access within minutes. What I need is lower price. And one of the key complaints that we heard were customers said, look, if I build a tape library and manage it myself, I can eke out a solution that might not be quite the same, but will cost less than Glacier. I think we've solved that problem by launching Deep Archive, which is more than 75% less than Glacier in our largest commercial regions, and still a significant reduction in our smaller and non-public regions. Customers told us that managing those tape libraries just takes work. Anyone in the audience here who's ever managed a library, I'd love to chat afterwards if you disagree, but it takes a lot of time, a lot of specialized knowledge. You need the space, you need the media, you need to maintain the environmentals, you need to do testing, migrations as the media and the drives themselves to turn over generation by generation, and the validation. It's a classic example of the undifferentiated heavy lifting that AWS has a long history of developing features and services to take off of your hands. Now when we built Glacier Deep Archive, we wanted to be crystal clear that we were not going to compromise on the durability or the availability. So just like Glacier, 11 nines of durability, 99.9 availability, and one of the real value propositions here is that you're able to get exactly the bytes that you request back within hours or days. You don't have the volley of, hey, I sent this off-site, I believe it was in box 1703, I believe it was media cartridge 1846, and lo and behold, the wrong box is returned and you have to wait a whole nother day for that to come back. If you request a specific object or series of objects to be restored from Glacier Deep Archive, you will get that exact object back within 12 hours using a standard retrieval, or within 48 hours using a bulk retrieval at a cost savings on those retrieval pricing. There's no need to worry about those human errors which are often introduced by managing offsite storage. So I wanted to step back from that and talk a little bit about the common use cases, not just for S3, but particularly for workloads on S3 that also make great use of our archive storage services, both Glacier and Deep Archive. And backup and recovery is one of the easiest places to start. If customers are perhaps managing some workloads on premises, and a scenario that we often see is their business is growing, their scale is increasing, they do want to have some redundancy. Maybe they don't want to continue increasing the volume that they have in their off-site location, or maybe they're managing redundancy in a single location, but as they're growing, they don't want to continue to purchase additional hardware. So to just back up to S3, and particularly straight into Glacier or Deep Archive, is a great solution for customers who are just in the early stages of their cloud migration. It also works very well for customers who are completely or well on their way to the migration, because you can back up to a different AWS region and provide some geographic redundancy, so that in the event of any type of disaster, whether it's a system issue or a natural disaster, you can fail over to your alternate location. Photos and videos are another great use case. There's an awful lot of media out there. Those files are quite large, And what we hear from many customers is that the access pattern decreases quite significantly after, sometimes as briefly as the first hours or days, but certainly when you're into weeks or months. And the raw or native file format is often not the one used to serve it up for consumption on a mobile device or in a web browser or whatever format is necessary. So many customers are choosing to take those native images and preserve them in Glacier or Deep Archive so they have access to them in the future if they need to retranscode for 8K, 16K, whatever the next file format, which no one's even thought about yet, comes, to be able to retrieve that rich original copy and adapt as necessary. This is another place where the tape replacement opportunity is quite large. There's no need to continue backing up this original media content to tape and making sure that you have the right hardware to read it and the right software to work with the tape architecture you've designed, and again, back to the environmentals and everything else. And the last use case is for data lakes and analytics. We see so many customers that are just gathering such an increasing volume of data as they build machine learning applications and offer recommendations to their end users and other similar use cases. And that data is extremely valuable to train new models in the future. And what we've seen in the early days with Deep Archive is customers before were making a value judgment on how long do I hold this data, and at what point is it no longer worth continuing to maintain a copy, because the likelihood of me needing it and getting some value to my business from this copy is sufficiently low. Well, with Deep Archive, what we've done is we've extended the period, extended the time which those conversations are had and when those decisions need to be made, which is terrific. Deep Archive is a great place to park those log files, that source data, which can be so incredibly valuable to run analytics on, and have them available to you at whatever point in the future you need them to train a new model, to retrain an existing model. And that's one point in particular that is worth noting. Again, it's very early days. Deep Archive launched about 2.5 months ago, and the early adoption has been fantastic. But we'd love to hear from you, from our customers, about what it is that would make Deep Archive an even richer and even smarter archive for your data, so that we can take that into account as we think about what features we'll build next for Deep Archive, for Glacier and S3 as well. So to get a little bit deeper into what Deep Archive is, we very deliberately designed it to be quite similar to Glacier. And the reason was we didn't want to create additional work for our customers to learn a new API, to learn a new way to interact with the storage class. So if you're familiar with using Glacier as an S3 storage class today, you are very well prepared for using Deep Archive. It's really just a simple change to the storage class from Glacier to Deep_Archive. The key differences functionally are the retrieval options have changed. With Glacier, you have 3 options: expedited, standard, and bulk. They'll get your data back within minutes in the expedited scenario, 3 to 5 hours standard, and 5 to 12 hours in a bulk retrieval. Now with Deep Archive, we've changed the stakes and we've eliminated the concept of an expedited retrieval. There's nothing fast about accessing your data in Deep Archive. Made a standard retrieval within 12 hours and a bulk retrieval typically within 48 hours. The other thing that we've just changed slightly is the minimum object duration. As some of you may know, with Glacier, that's a 90-day minimum duration, and that's duration in the storage class, not life of the object. Remember, your objects can move between storage classes. You need to stay in Glacier for 90 days. You need to stay in Deep Archive for 180 days. And the reason for that is it's a signal that this is meant to be long storage. This is data that we expect to live for more than a year, more than 2 years, potentially more than 10 years. Deep Archive is not a quick stop. So with those basics, I'd like to walk through how we recommend using Deep Archive. There's quite a bit of overlap here with using Glacier itself, so it's a great opportunity to refresh on best practices for using Glacier, and I'll highlight the distinctions between Glacier and Deep Archive along the way. The first way is to directly put your objects, and using the S3 APIs with a direct put, you can specify your storage class. It's an optional field, so without specifying, your objects will end up being put to S3 standard. You can elect to put them to any of the 6 S3 storage classes, including Deep Archive. You can do that through the AWS Management Console. You can do that using the AWS command line interface, or you can do that using the AWS SDK. So really whatever's most natural for your workflow. It's not unusual for many new customers to start with the Management Console and then to build an application either on top of the CLI or on top of the SDK as their team, whichever suits their team's preferences. Another way is to copy an existing S3 object. Great example of I'm looking to take a copy of what I have and just keep a backup. And I may do some processing on the copy, I may down transcode, but I want to make sure that I keep my original object in a low-cost, long-term, secure location, and Glacier Deep Archive is a great solution for that. So you can copy from any frequent or infrequent access S3 storage class. The one caveat I'll mention here is you cannot copy an object that's in Glacier or in Deep Archive. Because of the asynchronous nature of these classes, you'd first need to restore the objects, at which point then you could make a copy. Now the policies are where it starts to get a little bit more interesting and gives you a little bit more creativity to use some AWS tools to better manage your data. So you can move objects into both Glacier and Deep Archive using a lifecycle policy or a cross-region replication policy. Let's first talk about lifecycle. And with a lifecycle policy, you can design a policy which applies to an entire bucket, a prefix or a tag, and you can define policies to move objects among the AWS storage classes as they age. The triggering event there is age of the object. It's not last access date, which is important to keep in mind. So you could, for example, set a policy that moves objects after 30 days to infrequent access and after 90 days to Glacier Deep Archive. That S3 is continuously evaluating this policy, and it shifts the data once the object has aged past the trigger which you defined. Happens in real time. If you set it for a certain day, your billing adapts and your customer experience will adapt automatically. Very similarly, cross-region replication, it will move actually not your object itself, but a copy of your object to another region. So say, for example, you had a workload in the US GovCloud East region, and the specific program you were working on had a requirement that you keep your data, a second copy of your data, at least 1,000 miles separated from the first. You could set up a cross-region replication policy on that bucket, so every new object that you put in would be replicated to the US GovCloud West region. You would have as soon as the object hits the bucket in the source region, you would have a parallel request to replicate that object, move it across the country. You would pay a bandwidth transfer cost for the inter-region data transfer, and you would have a second copy in that other region. Now, the really interesting part about those cross-region replications are you can specify the storage class that they land in. So if, using the example I did in the lifecycle policy, you kept that data warm for processing for say the first 30 days, but your backup copy you never intend to touch unless there was some emergency, you could send that cross-region replica straight to Deep Archive and enjoy the low-cost storage that Deep Archive offers from day one. To get a little deeper on those cross-region replication workflows, should have pushed this about 10 seconds ago, you can also do some interesting things to secure your data if you're, for example, protecting against an accidental delete. You could change, for example, you could change the object owner in the destination region, and that way introduce some separation of control. Or maybe you have a different owner of your archives. Because you now have two different buckets, which will have consistent indices and identical objects, you can manage the control using our identity and access management policies to suit your organization's needs. And to come back to the lifecycle policies, this is another great example that we often give. When you're going to Glacier or Deep Archive, it can be challenging if you do that prematurely. You have to think about, am I ready for this asynchronous access? And one option that we often recommend is, if you're not sure, stage it in infrequent access. Yes, there is an additional lifecycle policy. There is an additional request. Every time you move storage classes, you pay a per object request fee. So this isn't a free staging area, but you can stage in an infrequent access class and you would have millisecond access to your objects. It's a great solution if you're defining a new experience. You don't fully understand what your end user's needs will be. It's excellent to know that you can save some storage costs by moving to infrequent access, while also being able to serve that immediately if you're not quite sure what the defined end user experience will be, versus going to Glacier or Glacier Deep Archive, which will have a larger impact on your monthly storage costs. However, if you move prematurely, you're introducing a minutes to hours delay to provide that data back to your end user. So that's a great way to test and develop the experience. I will say on that point, it is always more cost effective to identify the storage class that best fits your usage and go directly there. Every time you change storage classes, you do pay that per object request. If your objects are larger, that request tends to be less noticeable, but it is still there. And if your objects are smaller, if you're in the low single-digit megabyte range, that lifecycle request will be real dollars. And it is correct in some cases to build a workflow that moves through a number of classes, but when you can develop the confidence to go directly to your intended storage class, that will be your most cost-effective design. Another lifecycle example here, you could, for example, stage some data in Glacier and move it to Deep Archive once it's past the tier where same-day access is perhaps not as important. In this example, intelligent tiering is a great solution to give you the ability to save in the early days and not have to think about that manual configuration. But then in this example, you could put some data into Glacier, know that you could do an expedited retrieval if there was some emergent need for that data, and have it back within minutes. You could get it the same day in 3 to 5 hours, and move to Deep Archive, in this case 2 years out, where, for example, if this was data from an autonomous vehicle or a map gathering exercise, after 2 years, the theory may be that you've generated new data on the same route, and it would be much less likely that you'd need access to that 2-year-old data. And in the event you did, you certainly wouldn't need that within the same day. Great way to use Glacier as a transition on your way to Deep Archive. Another way to use Glacier Deep Archive is with the AWS Tape Gateway. Tape Gateway is an option within the AWS Storage Gateway, and it's a fantastic way to meet your existing workflow managing tape exactly where it is. And I would actually go as far as recommending, if you're managing tape today and you still have a daily or weekly or any regular cadence where a courier comes and picks up boxes of tape media and takes it to offsite storage, I'd love to hear about that, and I'd love to offer you an option to stop doing that as soon as next week. And this solution right there is AWS Tape Gateway. Your existing workflow will not need to change. Your existing software will not need to change. Tape Gateway acts as a virtual tape drive. And the way that plays out is think about a virtual tape which is a bucket in S3. And you put that data through Tape Gateway onto that tape just as you would to your Fuji tape that's sitting in your IBM tape drive in your data center. And the moment that you click eject, you have the choice to either eject that to Glacier or eject that to Glacier Deep Archive. You're really just picking which shelf in the storeroom in the basement it goes to. Again, you'll pay Glacier or Deep Archive storage rates once you do. In the event you need that back, Tape Gateway is built on our standard restore, so you can have that data back if it's in Glacier in 3 to 5 hours, within 12 hours if it's in Deep Archive. We just don't think with Deep Archive there's any reason for folks to continue managing physical tape, and we believe that not only is it easier, but it's also lower cost. And again, on ingest, beyond Tape Gateway, we have a whole host of other AWS services to help bring your data in. We have Snowmobile, of course, which many of you may be familiar with, our Snowball at a slightly easier to move scale. We can put an AWS Direct Connect, a high-speed link from your location or your existing data center right into AWS, so your data does not need to traverse the public internet. If SFTP is your preference, we have AWS Transfer for SFTP, and Data Sync is another fantastic new service to just make managing that ingest from your existing data repositories a little bit more natural. Now, once the data's in, it's important to come back to how to get access to the data. And this is where the archive or the asynchronous storage, infrequent access S3 storage classes are a few of the labels that you'll hear thrown around, really differ from the frequent and the infrequent access. And that is, unlike in S3 standard or standard infrequent access, a get will fail. That is by design. It's a feature, not a bug. You first will restore the object, and when the restore has completed, there's now a copy which has been staged in Amazon S3 reduced redundancy storage, which you can get and you can interact with just like an object that's in a frequent or infrequent access storage class. We have many customers who've actually built workflows where their application that sits on top of S3 is not aware of which storage class the object sits in. And what they do is they build some logic so when they issue that get and it fails, they follow it with a restore, because you'll get a very specific error message that you can infer a restore is now necessary. So that's one option. We also have a number of other ways that you can inform your application of where the object is. An interesting feature that we launched last fall at reInvent on the restores is you can now configure a restore notification. So the interesting part about the restore process is, while we give you a range, when we're able to, we will deliver those restores earlier. Now, I caution folks not to build logic or certainly make commitments to end users that those bytes will be back faster than the ranges that we offer, because that's not a guarantee. But in periods where our usage patterns are favorable, we'll get you those bytes back as quickly as we're able to. And because there's that uncertainty, and in the case of, for example, a deep archive bulk restore, within 48 hours is quite a long time. And there's value to processing that data as soon as it's available. So you can configure a restore notification. You have 3 options there. You can have an Amazon SNS message, an Amazon SQS message, or you can trigger a Lambda function, which will trigger as soon as the restore is completed and the object's available. And whether that your team or your application that the object is there for a get to be issued or processing to begin, or you automatically build some logic on top of that, it allows you to dehumanize the effort of managing those times, polling to check the status or anything like that. We have a really interesting customer workflow where they store a series of media files in Glacier, and they're moving to Glacier Deep Archive with their older data, and they sell consumer goods with media printed on it. So it could be a picture on a coffee mug or a a mouse pad or stickers, anything like that. And they've built a workflow, and they've defined their customer experience such that their customers can look at thumbnail images, which are much smaller and are stored in a warmer storage class. And when the customer places the order, they'll initiate a restore of the high resolution original format image. When that restore is completed, a restore notification will trigger a Lambda function, which will take that native file and begin the processing and take it all the way to the point where they've created whatever it is their customers purchased, and it's ready for a human to intervene and quality check and package for delivery. Really interesting use case. I think there's so many other great examples in that same space. To step back a little bit from that point and talk about the broader architecture of a system which uses Glacier and Glacier Deep Archive. Your data can come into S3 from any number of places, whether it's Lambda, a container, an EC2 instance, or frankly, this could be data in from the internet. When you initiate that restore, that restore request would come either from a Lambda function, a container, an instance, your software layer that operates on top of S3. You wait for the restore triggers your function, and your application picks up with those bytes and continues. Again, just to recap on the Glacier and the Glacier Deep Archive differences in the restore experience, really important to remember, expedited is not available, not an option for Deep Archive. And you really think about the Glacier Deep Archive standard as being similar to bulk from Glacier, and then Deep Archive bulk going beyond that. Important to note that the pricing and the time are inversely related. So the faster you want the bytes, the more you're going to pay. That's both a per object request as well as a per gigabyte streamed back to you. And the concept is really built on the fact that the more time that we have, it allows us to optimize the reads and the writes in a way that maximizes utilization. And if we can maximize utilization, we can spread the cost of those resources we're utilizing across more workloads, and therefore offer the benefit of that increased utilization to our customers in the form of a lower price. That works for both the storage price as well as the request price, which is how we've designed the system. Also important to note, we believe it's really important to meet customers where they are with their data. We don't want to force unnatural contortions to be able to take advantage of particularly our low-cost storage offerings. So we're working actively on integrating with these 6 partners. Veritas and Commvault announced support for Glacier Deep Archive on launch day, which was fantastic. And we're deeply engaged with Rubrik, Druva, Cloudberry, and Cohesity as well, among others in the storage segment for Amazon partners. If there is a partner that any of you folks are working with today, and you're struggling to fit that workflow, to fit that software, which you depend on from the partner in your workflow, into an AWS scenario, please grab me at the Meet the Speaker sign. I'd love to learn more about that, and I'd love to engage our team with the partners and make sure that we can meet you with the software that works for your business today. So economics are important to think about here, and particularly in the archive space, right? Less than 1/10 of a cent per gigabyte per month. That number, it turns a lot of heads, it catches attention, but it is not the whole picture. Yes, with storage, what you pay month over month, in the fullness of time becomes a significant portion of your bill. However, there are 2 other vectors that are important to think about. You have ingest cost and you have access cost. And if you focus exclusively on the storage price, sometimes expectations become mismanaged, and even though there are savings, there can be some difficult experiences if there's not a thoughtful model or analysis done of the entire total cost of ownership. So to walk through that with a real example, let's talk about a typical workflow. So you've got 250 terabytes that you'd like to put onto S3. It's 50,000 objects. So these are big files. Maybe they're media files, maybe they're clustered satellite images, or who knows. But we'll call it 25 gigabytes on average, and very low access, less than 0.5% a month. So this is a perfect workload for Glacier or for Deep Archive, because you're not touching most of it, and you can get what you need using one of our restore options. So just to map out the total cost for 12 months and compare Glacier to Deep Archive, you'll have a put request, assuming this comes directly into the storage class. You'll have 12 months of storage at the appropriate storage charge. I should step back and say these are costs for our large US regions, so Northern Virginia, Oregon, Ohio. And if you decide that your access requires standard, so maybe you're okay with 3 to 5 hours with Glacier, and within 12 on Deep Archive works as well. Perhaps you've built an application on top of this that just doesn't specify your restore speed when you make the request. That'll default to standard. So you'll factor in your monthly standard, both per object retrieval requests and per gigabyte streamed back. And you'll see the total cost over a 12-month period. It's pretty close to that 75% discount that Glacier Deep Archive offers, because your objects were big enough that your put requests didn't dwarf your storage, and your access patterns were low enough that difference in retrieval pricing between Glacier and Deep Archive didn't meaningfully impact your total spend. However, if your access patterns had been slightly higher, that may not have been the case. If your objects had been slightly smaller, those put requests might have been a bigger number. So that's why it's important to both think about the total cost of ownership for any given workload, even if you've already decided which storage class is right. But it's really important when you're doing an economic comparison between two storage classes to build that whole model and make sure you understand. Those numbers change storage class to storage class. And for some of the S3 classes, there's a difference between a put and a lifecycle as well. So it's important to think about the ingest vector that is appropriate for your workload. Now, if you shifted to bulk retrieval, in this example, the difference is not quite as stark, but your bulk retrieval requests and the bytes retrieved, the pricing dynamic changes. And in this case, bulk pricing is the same. So it doesn't matter if you're using Glacier or Deep Archive, same price to get those bytes back. The reason standard differs is because we built this concept of the faster restore tier is a premium to the lower. Standard, remember, is middle of the road for Glacier because you have expedited as an option. But when you're into Deep Archive, it's just standard and bulk. So the separation required a slightly higher retrieval request rate for Deep Archive. And again, when you're doing these TCO analyses, it's important to benchmark an apples to apples comparison, right? So if you're thinking about, well, I've got an on-prem tape library, I'm looking at Deep Archive, how does this really work for me? Well, don't forget, you need space for those tapes, you need power for that library, you need to manage the environmentals, that's cooling, that's network. You also have a humidification and particle filtering if you're really focused on keeping those tape media cartridges in the intended range. You need servers to manage that. You need tapes to put in the drives. You have to migrate tape generation to tape generation. So are you looking at LTO7, LTO8? What does that turn into in the future? Do you have to send some of this off-site? Do you need to manage transportation logistics? Do you need to engage another vendor and pay them for storage? You often pay them on the way in, and then you pay them for access. You need people to manage that process, and all of that, it takes time and money, which is an opportunity cost. And while that may be tougher to quantify in and of itself, even putting the opportunity cost aside, it's important to cover each of those pieces to do a true apples to apples comparison. Just step back and recap a little bit on how the storage classes compare. Again, frequent and infrequent access, you have millisecond access to your data if you need that quickly. And there is some data that is not well suited for Glacier or for Deep Archive, right? If there is a mission critical, business critical need to have that data right away when you need it, infrequent access might be the best destination for it. However, if you can wait minutes, but you need that minutes option across an unpredictable portion of the set, Glacier is a great solution. Alternately, if you can wait hours or even days, Deep Archive is for you. And again, when you look at pricing and you think about the comparison, the storage cost and the retrieval cost, you have inverse proportions there. So with S3, you have no retrieval cost, S3 standard, I should say, but your storage cost starts at 2.3 cents and at scale reduces to 2.1, again, in our large US commercial regions. With Deep Archive, you're talking about less than 1/10 of a cent, but your retrieval costs using a standard retrieval have increased in a meaningful way. A couple other factors to consider when you're thinking about economics. I mentioned frequency of access because that's how many times you'll be paying for both those requests and the bytes, but your object size is really important. Small objects present a challenge, and they present a challenge for two reasons. The first is you're paying per object on the way in and on the way out. So the more objects you have, the more of those requests you'll have. That can really create a pop on your first bill when you go to Glacier or Deep Archive. And if you model the total cost and factor in the life of those bytes, it may turn out to still be economically preferred, but you'll want to understand where that break-even point is. A great example would be for smaller objects, you may break even and begin saving money accounting for the storage cost 6, 7, 8 months after the transition. That's okay. The folks in the finance team usually like to hear about that before the bill comes in, especially if you're saving the object for 3 to 5 years. But if you're only saving the object for 24 months and your break-even point is month 18, are you okay with that? Or would you rather save the move and say, for a 24-month duration, I'd rather stay in infrequent access or choose a different path. So it's important to consider that. The other issue on object size is Glacier includes a per object overhead on small objects. So as many of you may know, for S3 infrequent access, there's a minimum threshold. We don't have the minimum billable threshold, but what we do is we charge for 40 kilobytes of object overhead. What that does is it manages your user or system defined name of the object with our system generated name. And we charge 8 kilobytes of that at the S3 standard price. That's what links it back to the S3 index. And then we charge 32 kilobytes at the storage, at the price of the storage class where the object is stored. It actually lands just ahead of your bytes in the sequence. So again, if you have objects, email messages, for example, that might average 50 kilobytes, well, when you build your model, you're not modeling 50 kilobytes at Deep Archive, you're actually modeling 90 kilobytes at Deep Archive. And to go deeper, it's 82 kilobytes at Deep Archive and 8 kilobytes at S3 standard. So that, again, it changes the inflection point, it changes the break-even point. It may still work. However, many customers are increasingly focused on managing that ingest request experience. And as your objects increase in size, the overhead, it becomes noise, it becomes unnoticeable. And the impact that the requests costs have also becomes less noticeable. So if you can aggregate at a logical clip, maybe it's per user, per day, per hour, per week, and you combine those, simple workflow using a Lambda function, roll it into a tar, a zip, there's so many options today. That's a great way to manage your cost for using Deep Archive and Glacier, and to get ahead of it while the objects are still warm, because once you've moved them in, you've already incurred the cost and you'd have to rehydrate with restores to be able to change that model. Worth mentioning also that Deep Archive has, in the 2.5 months it's been available, generally available, it's been the fastest growing S3 storage class that we've ever launched by 3 times. That's really impressive at Amazon scale, and we'd love to continue feeding that funnel. Again, as I mentioned, 95% of the features we launch come directly from customer feedback. So if there's anything that would make Deep Archive more valuable to you, anything that would make those bytes in Deep Archive smarter, better, easier to manage, I'm going to head out to the Meet the Speaker sign after the session. I'd love to hear from you directly. Please feel free to reach out to your account teams, your SAs, your TAMs, anybody with an AWS lanyard, and they will probably direct you back to me or someone on my team. But happy to support the ever-increasing workflows in the archive space. Thanks for your time, and enjoy the rest of the summit.